So in this video, I'm going to be going over sections 3 and 4 from chapter 12 to finish up our review for this chapter. So getting into section 3, this is when we started doing operations with our radicals. So we were adding, subtracting, multiplying, dividing, all of that stuff. And we were trying to write them in simplest form. We also talked in this section about how you need to sometimes reduce a radical before you can try to simplify it or combine it with something else. So remember when you're adding and subtracting radicals that the pieces underneath the radical sign have to look exactly the same in order for you to add or subtract them. Just because they may not look alike at the start though doesn't mean that you can't actually add or subtract them. So that's when we got into like simplifying the square roots. So if you need to simplify something first, start there and then try to see if you have any pieces that are the same so that then you can add or subtract them. For example, on my first one here, I have 12 radical 11 minus 5 radical 11. They both have the radical 11, which means that I can go ahead and subtract these. So I just take 12 minus the 5, and that's 7. The square root of 11 is unchanged. So don't try to subtract that piece. That's just going to kind of attach on. Think of it as like a variable. So if you had 12x minus 5x, you would have written it as 7x. So that square root of 11 is acting like a variable would. It doesn't change. It doesn't become something different. Now number 2, when it has the square root of 2 plus the square root of 8, this is what I was meaning when I said that sometimes you have to reduce first before you can actually simplify. So I'm going to leave the square root of 2 alone, but for the square root of 8, I'm going to change that to 4 times 2. Now the square root of 4 is 2, so that pops out front here, and now I have the square root of 2. So now they're alike each other, so we can actually add them. Remember, in front of the first square root of 2, there's technically a 1 sitting here, and so that's how I got the 3, because I did 1 plus 2, and so I got 3 square root of 2. Same happens with number 3, where we have to simplify them first. So I rewrite the 40 as 4 times 10. And again, when you're rewriting the radical, you're looking for a perfect square that goes into that number. So 4 is the biggest perfect square that goes into 40. 9 is the biggest perfect square that goes into 90. So I have 4 times 10, 9 times 10. So the square root of 4 is that 2. And the square root of 9 is 3, and now that they both have square root of 10s, we can go ahead and combine. So 2 minus 3 is negative 1, so they're just going to write that as negative square root of 10. You can put the 1 here, but most people, if they're writing it in proper form, are not going to have that negative 1 sitting there. Okay, so now we're getting into multiplying a little bit here and like using our distributive property. So for the first one, the square root of 6 times the square root of 3. When you're multiplying or you're dividing, you can go ahead and just operate with the numbers that are underneath the square root signs. So I can take 6 times 3 and get 18. Now that I have 18 though, I would then want to break that apart to simplify it. So 9 is the biggest perfect square that goes into 18. So I rewrite that as 9 times 2. And then the square root of 9 gives me that 3. So my final answer is 3 radical 2. For the second one, I have 2 times the square root of a, and then times the square root of b. So 2 is going to be unchanged because there's just a 1 sitting in front of that square root of b, so 2 times 1 would be 2. But then underneath the square root sign, you're just going to combine the a and b, so they just sit next to each other now. And we're not going to be able to simplify this at all anymore from this point. Now number 3 is wanting you guys to use the distributive property. So imagine arrows being drawn from 5 into the parentheses there. So we have 5 times the square root of 3 and then 5 times that minus 2. So we get 5 radical 3 minus 10. When we got into multiplying two binomials, so that would be two different quantities that each have like maybe a square root part and a whole number part, and there's a plus or minus sign separating them. This is when I wanted you guys to use your FOIL method. So our FOIL is you multiply the first, outside, inside, and last terms in that order, and then you simplify. So for the first one, I took the square root of 7 times the square root of 5, and I got the square root of 35. And then outside terms would be radical 7 and the minus 3. So I got minus 3 radical 7. And then negative 5 times radical 5 would be the inside terms. So I get minus 5 radical 5. And then negative 5 times negative 3 should be 15, so plus 15 there. Now I can't simplify this at all. I cannot break down 35. There are no perfect squares that go into 35. Like 4 doesn't work, 9 doesn't work, 16, 25, none of those work, and then 36 is too big. I can't combine the middle two radicals because they're different. I've got one that's radical 7, one that's radical 5, so I have to keep those apart. And then of course 15 is just a regular number, so it can't be combined with any of those things either. So if you can't simplify, you would just have to leave it like that. And sometimes that happens. Not all the time. Most of the time we're able to kind of simplify some things, but there is that chance that once you do the math, once you FOIL, you can't do anything from that point on. For the second one, we did talk in class about how if you've got something like this one where they're the exact same except one has like a subtraction sign and the other one has a positive sign, that when you FOIL, we would do the same steps. So radical 5 is radical 25. The inside and outside terms are going to be the exact same, but they're going to have opposite signs. So notice how I have positive 8 radical 5 and then negative 8 radical 5. So these are actually going to cancel each other out. And then I have minus 64. I can simplify the square root of 25 as 5. So I end up with 5 minus 64, which ends up just being negative 59. So kind of a shortcut that I talked to you guys about was when you see a problem like number 2, where it's the same quantity, but you have a plus and a minus sign, you can kind of skip over those middle terms if you want and just do the first. So just square that radical 5 and then just square the 8 and put a minus sign in the middle. And then just evaluate with those numbers. And you'll end up with a whole number for these type of answers, sometimes positive, sometimes negative. Then we got into division. So like with multiplication, you can go ahead and just operate with the items underneath the radical signs and then simplify if needed. So what I did for the first one is I actually just looked at the numbers underneath my square root signs, the 90 and the 5, and I divided them. So 90 divided by 5 is how I'm getting this 18 here. So I have 2 times the square root of 18. Now the square root of 18, I broke that apart on a previous slide, and I got 9 times 2, because 9 is the biggest perfect square. So that becomes a 3 when I square root this number. Now since there's a 2 already sitting here, when I take 3 out, I'm going to have to multiply that to the 2 here, and that's why I have 6. And then this 2 that's underneath the square root sign is just going to stay. So that's why I have 6 radical 2. For the second one, if you needed to, you could split this apart into like the top portion having its own square root sign and then the bottom one having its own square root sign too. But you can also just evaluate it how you see it. It doesn't make a difference if you separate it or not. So you're just doing square roots. With those numbers, 36 and 81, those are perfect squares, so that's why I have 6 and 9. Now with the letters, we saw a little bit of this in the last video with the other sections, that with the variables that have exponents, if it's like a square root, there's technically that little 2, that's kind of what the square root portion means. So you're just taking those exponents and you're dividing by 2. So x to the 8th power divided by 2 becomes x to the 4th, and y to the 10th divided by 2 becomes y to the 5th. The only other thing that I would want you guys to do is simplify the 6 over 9, because you can take a 3 out of both of those, and that's why I have 2/3 written there. Alright, and so the last section, section 4, this is when we started talking about that imaginary number I that came out when you were dealing with negatives underneath the square root sign. And what I'm going to have you guys focus primarily on is just operating with imaginary numbers, so adding, subtracting, and multiplying them. If it's adding or subtracting, you just combine like terms. So numbers can be combined with numbers, and then imaginary or like the complex numbers can be combined with other complex numbers. So for this first one, I have 5 plus 2, that's why I got 7. Now 3i plus a negative 7i, make sure you watch your signs. That's how I got negative 4i, because you're actually subtracting there. For the second one, because there's a minus sign in between them, that's going to go into both of these terms. So imagine like it being distributed in, if you can imagine those arrows there. So we have 4 minus 3, which is 1, negative I minus a negative 2i. So the double negative becomes a plus sign. So it's really negative I plus 2i, and that's why I got just positive I there. Multiplying, if they look like this, again, you're going to want to FOIL them. So first would be 10i squared, outside would be negative 15i, inside would be negative 6i, and last would be positive 9. Remember, I squared can be replaced with a negative 1, so you see how I have that in the next step. So I'm taking 10 times negative 1. Now I combine the negative 15i and the negative 6i to get negative 21i, and then I still have my plus 9. So 10 times negative 1 is going to change that to a negative 10. So really the last thing that I need to do here is just combine the negative 10 and the positive 9, and that gives me a negative 1 minus 21i. When you're writing your answers for these problems, they're going to want the whole number part first, and then the imaginary part, the complex part. Now this one looks just like a couple slides ago when we were multiplying, where we have the exact same quantity, but one has a plus sign, one has a minus sign. So you can use your shortcut again where you can skip over the middle terms, but I do have it all written out here for you guys. Just kind of follow with what I'm doing. So I've got 4i times 4i, which would be 16i squared. The outside and inside terms are both going to be 12i, but opposite signs, so those are going to eventually cancel off and go away. And then 3 times negative 3 is negative 9. So 16 times negative 1 minus 9, so we get negative 16 minus 9, which is going to simplify to negative 25. Okay, so that's what I want you guys to focus on for this chapter review. Make sure that you are practicing the problems that I'm going to be giving you and that you're submitting those to me. I will be available for questions over email if you need to, and we'll probably be having a test coming up then on this Friday. So if you need help or you need a chat or something like that, let me know, and if we feel like we need to do like a big group chat or something, we can. I can get that arranged. So just email me if you feel like you need something like that, or if you just have quick questions for me. We can make arrangements for like a one-on-one chat too if we need to.